So we're about to do a practice exam. Practice makes better, right? And so this is for an upcoming exam, which is going to be testing us on basics of functions and some financial mathematics. Now, one thing that's important is to do practice and get familiar with the problems. And you'll see that these problems are pretty good in terms of getting you ready for what you'll actually see. So I'm glad that you're doing this now ahead of time. The other thing is make sure you have the technology in place. You will need a scientific calculator for this exam. A graphing calculator is not allowed. And you also need to make sure you have a calculator which has the ability to do things like natural log, take exponents. So you need something that powerful. And pro tip, make sure you know how to use your calculator. The other day I was trying to figure out how to do a negative sign in this calculator, and I kept hitting the minus and it kept complaining. Syntax error. I didn't realize that you do a negative sign with this button. Now it's all funny when it's happening, but not on a test. It's not funny then. So make sure you know how to use your calculator. You don't want to try to learn it on the fly. All right. Well, we have 20 questions to go through. That gives us a lot to do, so we should be going. Number 1, true or false? This is a practice exam, and as such, the questions will be different from what will appear on the actual exam. This is true. That is completely true. Does that mean that you're like, oh, let's stop the video now? No. Keep going. It's not that we're trying to say, look, I can only do what I've seen before. No, it's, hey, I'm getting ready to see any problem they throw at me, I'll be able to do. All right, now let's get into the real problems. Number 2. Use the vertical line test to determine if y is a function of x in the graph. And we have 2 options. Y is a function of x, y is not a function of x. Now, notice this says vertical line test. So what is the vertical line test? Let's just remind ourselves of that. So vertical line tests can be phrased in 2 ways. The first thing is to say, when do you have a function? So if every vertical line hits your graph in less than or equal to one place, or places, then y is a function of x. A different way you can say this is if any vertical line hits the graph in at least 2 places, then y is not a function of x. So the vertical line test says, can I show that for every vertical line I hit in less than or equal to one place, yes, then it might be a function. If no, I'm not. So you're okay for something like this. This is okay because you hit no places. This is okay because you hit one place. But now, here, you hit 2, and you're like, not okay. So, because we have that vertical line that hits in at least 2 places, we know y is not a function of x. All right, so that's the idea. This one's going to be quick. Look at the picture, and you can almost imagine just scanning, I see a vertical line that hits in more than 2 places, stop. But if you go all the way through the picture and that never happens, then y is a function of x. All right. Number 3. Use the graph of a function f, here's the graph, to determine x or y to the nearest integer as indicated. Some problems may have more than one answer. Okay, so what are they doing? Well, they say 0 equals f of x. Now, normally, what do we think of? Well, we think of this as y equals f of x, and so we're saying, aha, what are we really saying? We're trying to say the y value is 0. So we were trying to find when y equals 0. So what do you do? Well, to find when y equals 0, you say, well, that would be this horizontal line is actually the axis. And we'll just draw it in. And now we say, when do we cross the graph of the function? And we look like we crossed it in 2 places. And this will be pretty obvious by eyeballing it. You don't have to be like, No, just look at the picture. Say, well, where are we crossing? Where do we hit? Well, we're crossing here at -2 and comma +3. And there you go. All right. Well, not too surprising, right? If you see, f of x equals a number, it's like, just imagine that horizontal line. Where do you hit the function? Now, if you see, y equals f of 0, well, that's like, when do you cross here? And so, again, not too bad. These are great. I hope the test is full of these problems. Well, at least I'll have one of them, right? Number 4. Describe the domain of the function. So we have the function g of x is x squared divided by the square root of x plus 4. And it says the domain of the function consists of all real numbers x where, all right, now, what do we need to watch out for? Well, there's basically 2 key things we're going to be looking for. We avoid, I don't know how to spell the word avoid. Avoid square root of a negative, because you can't do that, at least not in our class. It would be a very complex thing to do, but okay, we want to avoid that. And we want to avoid divide by 0. Okay, so looking for a domain, right now, those are sort of the things we're going to focus on. Say, okay, that narrows things down. We see a square root. So we're like, cool. And we say, okay, so since we see a square root, we know we have to worry about avoiding square root of a negative. So we say, all right, well, this tells us that we need the inside x plus 4 has to be greater than or equal to 0, or x has to be greater than or equal to -4. But we're not done yet. Just because we solved one problem doesn't mean we have another problem. Maybe we have multiple problems. Divide by 0. Can square root of x plus 4 ever be 0? Yes! Yes, it can. Okay, right? Because the square root of 0 is 0. So you say, oh, okay. Well, so that says, look, I need the square root of x plus 4 is not 0, or x plus 4 is not 0, or I can't have x be -4. So you say, well, what combines these 2 ideas? Well, x has to be greater than or equal to -4, but it can't be -4. So putting them together, this says x has to be strictly greater than -4. So that's what we're after. So we're going to say all numbers x where x greater than -4. And there we go. All right. Now, do we need to worry about anything upstairs? No. X squared is perfectly fine. You don't have to worry about the upstairs being 0. It's okay to have a 0 in the numerator. It's the denominator. Don't want it. Wouldn't be prudent. So be careful. All right. Number 5. Given the graph of f of x shown, sketch the graph of the function y equals f of x minus 3. Now, this f of x is already here. So the question is, what is this minus 3 doing? And there's some clues. Where is the minus 3 located? Is it inside or is it outside? An inside thing affects the input, so that's in the x direction. An outside thing affects the output. That's in the y direction. Well, this is an inside thing. So it's something having to do with the input. So it's something doing with this kind of action. And in particular, what we're going to see is that this corresponds to a horizontal shift. All right, so it's inside. So we're going to make some notes here. Inside, so affecting, I guess it's affecting. I can never remember A or E. So affecting inputs, which is the horizontal. All right, great. Well, so what does that tell us we need to do? All right, well, now we have to be ever so careful. How does that shift? Right, it's a left or right shift. We can see it's going to be a shift by 3, but which way? To the right or to the left? And now here's the thing. It's f of x minus h shifts horizontally by h. Okay? So it's this weird thing. So it's like minus 3 makes you think you should be moving that direction, but actually we're going to move this way because it's minus the shift. So since it's minus 3, we're going to be shifting by plus 3. So picture-wise, what's going to happen? Well, we can actually just say, since this is straight line segments, we just move everything across by 3. So I'm just going to move everything over by 3. And we get our new curve. So it's going to look, I'm going to draw it here. Okay, so there's our new curve. It's shifted by 3. Now, why does it do that? Well, you can think of to say, look, suppose I want to say, what gives me this output here? Now, that would be if I plug negative 1 into my function. So what value of x is it so that x minus 3 gives me negative 1? Well, 2. 2 minus 3 is negative 1, right? So when in doubt, just think about, okay, what do I need to plug in to get negative 1 or to get 0 or whatever it is? And you'll see, oh, I need to be moving up by 3. So that's why there's that sort of difference there. And other than that, it's pretty straightforward. Just remember, on the inside, horizontal. On the outside, vertical. And then it's not so hard to reason from there. All right. Well, we're moving pretty quick. That's good. That means we'll have plenty of time to finish. Number 6. The graph of the function g is formed by applying the indicated sequence of transformations to the given function f. Find an equation for the function g and graph g using negative 6 less than or equal to x less than or equal to 6 and negative 6 less than or equal to y less than or equal to 6. Okay, so in other words, what's the picture? All right, so we're told it's the graph of f of x is x squared is shifted 3 units to the right and 1 unit up. Okay, now, in general, when we're doing shifts, if I want to move, I would do the following. F of x minus h plus k. The h, we talked about in the last problem, this is a horizontal shift by h. So that's how much we move left, right. Notice that it's on the inside, that's why it's horizontal. The k, it's on the outside, that's the vertical. So that's a horizontal shift by k. And so it's affecting, not horizontal. Why did I write horizontal? It's a vertical shift by k. I know the problems. When you're on the outside of the function, you're affecting the output. That's the y values. So since we're doing shifts, we say, okay, 3 units to the right and 1 unit up. Be careful, right? Don't just say h is 3 and k is 1. Look for words, right and up. Okay, so is right a positive or a negative? Is up a positive or a negative? So if A had said 3 units to the left, that would be different than 3 units to the right. So pay attention to these words. Words matter. It's not just look at just the numbers and ignore the words. Words matter. All right, so we see we're shifting to the right. So that's the same as I was going to say horizontal shift. That's what I need to say. Horizontal shift is plus 3. 1 unit up, our vertical shift is plus 1. And now we're almost there. So what's our function? Our function is x squared. So we're going to plug in h equals 3 and k equals 1. So we're trying to do f of x minus 3 plus 1. And if f of x is x squared, well, if I'm replacing f of x minus 3, I come here and say replace x by x minus 3. So it would be x minus 3 squared plus 1. All right. Now, in terms of the picture, it's a little bit straightforward to see, right? Because normally the parabola, and f of x equals x squared, is a parabola here. But we're going to shift to the right by 3 and up by 1. So that's the vertex of the parabola, the bottom, if you will. And now we say, okay, just draw the picture. And it doesn't have to be super precise. And I will say, if you're like, what if I have a hard time drawing? Well, actually, on the test, you don't have to draw it. You have to pick out of a lineup. Say, okay, I have a lineup of potential graphs. Which one is the one I'm after? So that'll be good. But just understand, hey, think about what's going on. All right. Well, that's pretty good. And let's move on to our next problem. Number 7. Complete the square and find the vertex form of the quadratic equation. All right, so we have f of x is minus 2x squared minus 12x plus 17. Now, complete the square is one thing, but what are we trying to get at with when it says vertex form of the quadratic equation? So what that is telling us is we're trying to write it as the following: a times x minus h squared plus k. And what is happening is at this point, h comma k is the vertex. So this is why they call it the vertex form. In other words, it's sort of like the bottom of the parabola if a is positive, or the top of the parabola if a is negative. All right, so completing the square. How do we do it? Well, what I like to do is I'll start by writing the formula down, and then I say, what's in front of the x squared? Whatever it is, I want it to be 1. And if it's not 1, we're going to make it 1. And the way we do that is we're going to factor. So notice that currently what's in front of the x squared is minus 2. Say, all right, minus 2, we don't want you there. We want you to come out. So we're going to factor minus 2 out of the x squared term and out of the x term. So since I factor out minus 2, that's not so hard to figure out that the x squared is what's left. Minus 12, if you pull out minus 2, it's minus 12 divided by minus 2, which is 6. So we're going to put plus 6. And then we're going to leave a really big gap here and put plus 17. So I don't need to worry about factoring the minus 2 out of the 17. That's going to come out to the side. Okay, now, why did I leave a big gap? Well, because we're going to complete the square. And we needed to leave ourselves enough space so that we could do that. So complete the square says we really want this piece right here to be something squared. And the way you do that is you take the middle term, what's the x, or what's attached to it, including the sign. You say, all right, take that and divide by 2. 6 divided by 2, 3. Now square that. And if you do that, you get plus 9. Which makes x squared plus 6x plus 9 is now a perfect square. It's that x plus 3 squared. But you can't just add 9. That no longer is equal to what you started with. You've got to balance it out. So how do we balance it? Well, if you add 9, one thing we can do is right away subtract 9. Now, why does this work? Well, because we added and subtracted 9, this is going to become 0. And we can always add 0. All right, so updating, we have minus 2 times x plus 3 squared minus 9 plus 17, which makes it, if you distribute the minus 2 through, minus 2 times x plus 3 squared minus 2 times minus 9 makes a plus 18, then plus 17. So we get minus 2 x plus 3 squared plus 35. So that's the right form. So that's what we're going to put in. Minus 2 x plus 3 quantity squared plus 35. All right. Cool. And just be careful, right? Make sure you distribute and pay attention to the signs. Minus times minus makes a plus. And there you go. Now, if you're paranoid, you can always just work backwards and say, hey, does this get me back to what I started with? And if you have time, why not? It doesn't hurt to be extra cautious. But for now, let's move on. Number 8. Write an equation for the graph in the form y equals a x minus h squared plus k, where a is either 1 or minus 1, and h and k are integers. Okay, so let's talk about the a. So how do we figure a? Well, if our parabola goes up, then a is 1. And if our parabola goes down, a is minus 1. So actually what's happening is, because we're talking about 1 or minus 1, really more generically, if it opens up, a is positive, and if it opens down, a is negative. But because we're either 1 or minus 1, we can figure that out. Okay, so that's how we figure out what a is. So for us, a is 1. Now, we usually don't write 1 times x minus h squared, so we won't put that in. All right. Now, how do you figure out h and k? Where does that come into play? Well, you might recognize this. This is the vertex form. So this is if a times x minus h squared plus k, this is what we call the vertex form. And hk is your vertex. Now, what is the vertex? It's either the very bottom point or the very top point, depending upon whether you're opening in some direction or the other. So your vertex is over here. So you say, well, what's that point? It's at -3, 1. And so you say, or perhaps you say, oh, but you're going to say something. And so now we say, oh, we know what a is. A is 1. We know what h and k are. We found it here. And so we are ready to put it all together. Y is equal to 1 times x minus 3 squared plus 1. Well, we normally don't write the 1, and minus makes a plus, so this would be x plus 3 squared plus 1. And, all right, and we're not going to expand it, okay? Why? Because it says write an equation in this form. And our equation needs to be the whole thing. So the equation is, this is a time when we do include the y. Y is equal to x plus 3 squared plus 1. And that's it. We did it. Woohoo! All right. And, okay, good. Good. They really like parabolas here on this exam. Well, they should. Parabolas are beautiful, beautiful functions. All right, that takes us to number 9. Find the equation for any horizontal asymptotes for the function below. So we have f of x is 4x squared plus 7x plus 18 divided by 2x squared minus x minus 3. Now, horizontal asymptotes says, hey, think about what happens for really big values of x. So we're heading off in those directions and saying what's going on. Now, it turns out there's only 2 ways you can get big. You can get big in a positive direction or big in a negative direction. So there's either 0, 1, or 2. And so that's why you'll see there's 3 possibilities here. So how do we figure it out? Now, this function is what's called a rational function. And so for rational functions, the answer is going to be 0 or 1. You cannot have 2 horizontal asymptotes for a rational function. And so if you see a rational function, you know it's definitely not the one with 2 of them. So what do you do? Here's the easy way to do it. You say, if I'm very big, look at the biggest pieces. In other words, you have the 4x squared plus the 7x plus 18. For very large, for very large numbers, the 4x squared, that's your biggest piece. Here you have 2x squared minus x minus 3. Again, for very large numbers, 2x squared is your biggest piece. So if you look at the leading pieces, you say, okay, so this is approximately, this is for large x. We get, this looks like 4x squared over 2x squared. Everything else is small. Or this is approximately 2. So that says our only horizontal asymptote is 2. All right, so we have a horizontal asymptote. In general, you look at the powers of the leading terms. If the upstairs has lower degree than the downstairs, then what happens is the downstairs is small. The upstairs is small compared to the downstairs. You go to 0. If the degrees match, which they did in this case, then you say, look at the division of the leading coefficients. And that's what we're really saying is, hey, it really looks like the leading terms. And then you get that coefficient, the ratio coming out. If the degree upstairs is big compared to the downstairs, it says, hey, you're going to get a big number because the upstairs is dominating. It's huge. So there's no horizontal asymptote. All right, so let's mark this. There's 1, so this is the one we check. Now we have to fill in the box. And what is our horizontal asymptote? Well, I put in y equals 2 because that's what we're approaching. We're approaching the line y equals 2. And there we go. All right. Good. Good. And, okay. Just remember, for horizontal, look at the leading terms. That will determine what goes on. That brings us to question number 10. Find the equation of any vertical asymptotes for the function below. Now, for vertical asymptotes, that's when something blows up. Usually it tends to do this. What causes a vertical asymptote? Well, vertical asymptotes, they come from divide by 0. So if we're thinking that there's a vertical asymptote, what really is happening is there's some kind of division by 0 going on. So where we look is the denominator. Say, all right, Let's focus on that. Now, there are some subtleties about, what happens upstairs that we talk about in a calculus type class, not in our class, so focus on the denominator. All right, x squared minus 6x minus 27. We say, all right, when is this 0? And so we factor. So, okay, well, we got good at factoring before. If you don't remember how to factor, quadratic formula works great. So we have x squared, so it'll be x and x. And we need two numbers that multiply to negative 27, but add to negative 9. Now 27 is like 3 times 3 times 3, so there's only a couple ways to do it, like 27 and 1. No way you're going to get 6 from that. But 9 and 3? Yeah, we could do that. So if we had, say, a minus 9 and a plus 3, I think that'll do it. Let's check. X squared, good. 3x minus 9x, that is negative 6x, and minus 27. Whew. All right, so now we say the denominator looks like x minus 9, x plus 3, and we want to know, hey, when does this equal 0? Well, since we have a product, this becomes either x minus 9 equals 0 or x plus 3 equals 0, which becomes x equals 9 or x equals negative 3. So there we go. And so now select the correct choice below, and if necessary, fill in the answer boxes to complete your choice. All right, so let's see, how many do we have? We have 1, 2. So that's a 1, that's a 4, that's a 2. Oh, whoops, we missed a box here. Sorry, somehow when I was putting this together, there should have been a box there. Sorry about that. And there's a 3, and then there's a no. All right, so which one are we? We're 2. So the function has 2 horizontal asymptotes. There we are. And what are they? Well, they're at x equals negative 3 and x equals 9. It's here I would include the x. And I think on the exam they might specify, put them from left to right. So you want to sort them. X equals minus 3, x equals 9. All right, good. Because we want to get all the credit, right? We want to get all the points. That's what we're after. That's what we're after. All right. Well, 10, that means we're around the halfway point. We're doing great. Let's keep going. Number 11. Write an equation for the lowest degree polynomial with the graph and intercepts shown in the figure. For this exercise, make the leading coefficient be 1 or minus 1. Now, you say, well, how do I figure out lowest degree? Essentially, you should say, look, if count the number of wiggles, this has like no wiggles. This is going to be something like ax plus b. If you're a parabola-like shape, ax squared plus bx plus c. There's 1 up, down. And if you look something like this, which is what we have here, then you're a cubic. Ax cubed plus bx squared plus cx plus d. And it keeps going. So every time you add a new up, down, you basically keep going, right? So because I can basically say, aha, I have like 2 places where I'm turning around. 2 plus 1 is 3. This will be a third degree polynomial. Well, what do? We know the leading coefficient is 1. That's going to make our life easy. And it says use the intercepts. All right, so here you're going to clue off of the x-intercepts. So now you just say, okay, where are my x-intercepts? Well, the x-intercepts are, and we're making a list, they're going to make nice numbers. So we have one at negative 1, at 0, and at 2. Now, at negative 1, So think of these as x equals x equals x equals. We're going to think of this really as corresponding to like an x plus 1 piece. For x, we're going to think of that as an x piece. For x equals 2, we're thinking of this as an x minus 2 piece. So these parts right here, these are our factors of the polynomial. So what is our function? Well, the answer is our function f of x is going to be x plus 1, x, and x minus 2. Now, I've put it in a box here. And you're like, whoa, what's in the box? What's in the box? Why did you put a box? And the box here is for the leading coefficient, 1 or negative 1. How do you answer that? And the answer is actually surprisingly simple. You look and you say, what's happening on the right? So if on the right, so what happens on the right? We'll make a note here. So if you're going up, this corresponds to a equals plus 1, right? That's the leading coefficient. If you're going down, then that corresponds to your leading coefficient being minus 1. So the question is, are we going up or are we going down? Up is positive, down means negative. We are going down, so we need to put a minus 1 there. Okay, so what can we put as our answer? Well, we can actually just put it in like this. So we could say minus times x plus 1 times x minus 2. Perfectly valid answer. We could also factor it out. And, sorry, not factor out, but expand it out. So, for instance, here, we'll just do the alternative. So we have minus x, and then I'm going to take x plus 1 times x minus 2. That'd be x squared. Minus 2x plus x makes a minus x. And 1 times minus 2 makes a minus 2. So then distribute through, you get minus x cubed plus x squared plus 2x. So we could have also put in that as our answer, minus x cubed plus x squared plus 2x. That would get us the same number of points because they're equivalent answers. And so whichever one makes it easiest for you. So what's the punchline here? For this type of problem, look on what's happening on the right. Are you going up, plus 1, down, minus 1? And look for where you hit the axis. That tells you what your factors are. Now you put those together, and you got your function. Life is good. Life is wonderful. Number 12. Solve the given equation for x. Okay, so we have 3x e to the 2x plus x squared e to the 2x is equal to 0. Now, the fact that it equals 0 kind of says we know where we're going. We're trying to get to the point where we have a lot of stuff multiplying to get 0. So, how do we begin? Well, we start by asking ourselves the questions, what do these terms have in common? What do 3 times x times e to the 2x have in common with x squared e to the 2x? They both have e to the 2x. They also both have x. So we could factor that out. So that's x e to the 2x. Now from the first term, we didn't capture that 3. So 3. From the second term, we only got one of the x's, so there's still one x left. And there we go. Now, we go back to one of our tried basic ideas, tried and true concepts. Namely, if you have a bunch of stuff multiplying to 0, something has to be 0. So that gives us, well, maybe the x equals 0, maybe e to the 2x equals 0, or maybe 3 plus x equals 0. One of them has to be 0. They don't all have to be, but at least one of them does. Now, x equals 0 corresponds to x equals 0. That was pretty easy. And while we're at it, 3 plus x equals 0, well, that corresponds to x equals negative 3. What about e to the 2x? So this requires us to remember something about exponential functions. Exponential functions are wonderful functions. I like to think of them as being somewhat optimistic, because if you think about e to the x, which roughly is a similar graph to e to the 2x, what do you see about this function? It's always positive. So it's like the song. It always looks on the positive side of y. So this part can't be 0. An exponential function can never be 0. So what does that tell us? Well, this part here, it's not possible. It doesn't work. That's okay. That's okay. So what do we get? We get these last two pieces here. So our answer will be, since they already gave us x equals, we have two solutions. So we have a 0 and a comma, negative 3. And that's our answers. Nice! We have two of them. Woohoo! All right. Well, let's keep going. Wow. Now, number 13. If log base 27 of x is 2/3, find the value of x without a calculator. Ha ha ha! We could actually use a calculator if we wanted to. Why? Because they'll never know. How will they know? We have a calculator, but I think in this case, we don't need one. All right, so let's see if we can figure this out. So we're dealing with logarithms for our first time. Nice. And now we have to think, well, where do logs come from? I'm going to use parentheses. Even though this problem didn't use parentheses, I like to have parentheses here. So what are logarithms? Well, logarithms relate to exponential functions. Essentially, it's the undoing of an exponential function. So we say, okay, so if logarithms are undoing exponential functions, they're the inverse functions. The same is also true if we flip the script. The exponential function undoes logarithms. So, in other words, we have the following. So, note, we'll do it in the corner, b to the log base b of x is x, and log base b of b to the x is x. So this is the idea of hey, we can undo using exponential functions. So we say, all right, great. We know what our base b is. It's written in the log. It says 27. Now, if there were no number written there, that would mean log base 10, but there's a number here. So we say, okay, in this case, our b is 27. So we're going to say take both sides and feed it into 27 to the. What's going to happen? Well, this side will become x, right? We're just going through here. b to log base bx is x. And this side becomes 27 to the 2/3. Now, we're supposed to do this without a calculator, so it's very tempting. We can use a calculator, and we'll check it in a second. But here's how I like to do it. So I'm taking it to the 2/3 power. I'm thinking of it really as two things, to the 2 and to the 1/3. And I'm of the philosophy, make something small and then make something big. So here I think this says 27 to the 1/3 squared. And that's the property of exponents. Right? If I have 2/3, I can think of it as 1/3 times 2. the cubed root of 27, well, is there a number that when I multiply it 3 times gives me 27? 3 times 3 times 3. So that says the cubed root of 27 is 3, and 3 squared is 9. And like I said, they'll never know if you use their calculator, so we can even try this, right? 27 to the power 2 divided by 3, and that gives us 9. Okay, it works. The theory is true. So there's our answer. X equals 9. All right, good. Fun stuff. So basically, how do we do this problem? We take both sides to whatever the base is, and using the fact that these are inverse functions, we get the x out, and then we just have to evaluate. And if you use a calculator, we'll never know. You'll still get the points. We'll still give you credit. All right. Bringing us to number 14. Find x in the following equation. Log base 11 of x plus 6 minus log base 11 x minus 3 equals 1. So this is going to test us on a couple of properties of logs. Let's recall a couple of things. So we're going to do some recalling here. One of them says if I have log base b of, I'll call it x, plus log base b of y, that's log base b of x times y. In other words, addition becomes multiplication on the inside. Log base b of x subtract log base b of y is log base b. All right, if addition became multiplication, subtraction becomes division. So x over y. A few other things we'll note. We won't use all these properties, by the way, but it's good to know them. Who knows what you might need? Log base b of x to the power y, the power comes down. So that's one of the reasons why we like logs. It brings exponents downstairs. And one that we did on the last problem, and we'll mention again here, b to log base b of x is x. And technically we should note if x positive, and log base b of b to the x is x. All right, so these are our wonderful properties of logs. Now, what do we have? What do we see? We see coefficients of 1 and 1, and we see a subtraction. Say, okay, well, that tells us subtraction means division. So this is the same as log base 11 of x plus 6 over x minus 3 equaling 1. Now I want to get rid of the log. And I do that by saying, log is related to the inverse of exponential. So I'm going to take both sides and raise it to the 11. Why to the 11? Because that's base. That's our base. All right, so 11 to the log base 11 of stuff is stuff. So you get x plus 6 over x minus 3. And 11 to the 1 is 11. And now we're like, oh, so this problem was secretly not really a logarithm problem. They were just obfuscating a more straightforward algebra problem. Those obfuscators, they just go around obfuscating all the time, don't they? Yes, they do. So you get x minus 6 is 11 times x minus 3. Distribute that 11 through. That becomes 11x minus 33. Now we'll move some terms around. We can move this x across, and we can move this 33 across, and we'll get 33 minus 6 is equal to 11x minus x. Well, 33 subtract 6 is 27. And if you're getting uncomfortable with some of these computations, it's okay to use the calculator. 11x minus x is 10x. And we come to the conclusion, x is 27 over 10. Or we could say 2.7, but 27 over 10 sounds really cool. So I'm just going to put it there, 27 over 10. And I don't need to put the x equals because it already says x equals there. All right, nice, nice. So here we use the subtraction, and then we used how do we get rid of the logs? Taking both sides and put it 11 to the both sides. And then from there it was a more straightforward algebra problem, one that we're more comfortable doing. And there we go. There we go. Now, you might say, should we be nervous about this answer? And, okay, should we be nervous about this answer? Oh! I can't believe I messed this one up. Okay, let's fix my mistake. And this shows you how easy it is. Notice there was a plus 6. Plus 6. Okay, so that's a plus 6. And so what happens? This is 33 plus 6, making this not 27, but 39. And so x is 39 over 10. And so that's how easy it is to make a mistake. And yes, your math professors make them. We understand. Yes, we still take points off. And I sympathize with you. I know how easy it is to make mistakes. So be careful. Don't try to run through and do too much. Take your time. You can do it. Okay, let's get back to our regularly scheduled problem solving. Number 15. A loan of $1,200 was repaid at the end of 12 months with a check for $1,255. What annual rate of interest was charged? And the annual rate of interest was charged at, it says round to 2 decimal places as needed. Notice something here. They have marked percent. Okay, so we are going to make sure we convert to a percent. Because when we talk about rates, sometimes we say, oh, a percent, and sometimes we say move the decimal places. So we have to make sure we move the decimal places to the right location at the end of this question. So we're now into the financial math part. Woohoo! Yes! Okay. Now, what's going on? We have a loan. It goes for 1 year. And what's the annual rate of interest that was charged? And here, so we were just thinking this is just simple interest, one time, 1 year, the simplest thing we can be in. Now, for that, well, there's 2 basic formulas. One, you can say the interest is your principal, or present value, what you took, RT, or you can say the amount is equal to P times 1 plus RT. And what are we solving for? We are solving for R. And so we say, okay, great. Now these equations are equivalent. It just basically says the amount you owe, it's the principal plus the interest. All right, so let's think about what's going on. What is our interest that we paid? Well, notice it's the difference. So if you take the interest, that's $1,255, subtract 1,200, and that gives us 55. All right, so there's our interest. Now, we say, cool, we have, how much did we borrow? So this here, P, is built off of this amount. So this is your P, and this part right here, this is your P plus I, your principal plus interest. So we get that 55 is equal to 1,200 times R times 1 year. I know it says 12 months. 12 months is 1 year. Okay, so what do? Well, that says R is 55 divided by 1200. 55 divided by 1200. Good. So we turn on our calculators, take 55, divide by 1200, and we get 0.0458 and a bunch of threes, right? Now, that's our rate as a decimal. But we don't want rate as a decimal. We want rate as a percentage. So what do we need to do? We need to move it over 2 places. So essentially multiplying by 100. So the rate that we get charged was 4.58. Now we say how many decimal places do we need? 2 decimal places. And after that, we're threes. So we round to 4.58. We don't need to round up. We're going to be rounding down to 4.58. So that is the answer. Now when we type it into here, what do? The annual rate of interest was charged at, we put in 4.58. All right, that's not so bad. That's a pretty reasonable loan. They must be nice people, friendly people. Probably getting the family discount for that one. All right, well, good. Let's go to the next one. Number 16. Use the continuous compound interest formula to find the indicated value. So we have A is 18,541, P is 14,800, T is 48 months, and R is something. All right. So, okay, good. Now, which setting are we in? We're in the continuous compound interest. So there's a key word here. So when you have continuously compounding interest, then that makes the formula very easy. That says the amount is going to be what you started with, P, E to the R, T. Now, what is T? Be careful, because they're going to throw stuff at you. And here, 48 months, well, that's 4 years. We measure our interest rates are tied to years and not to months. So what do? Well, we put in what we know. We have 18,541. That's our A. Is equal to 14,800. There's our P. And then we have E to the 4R. Well, good. And now we start cleaning up. Okay, so we'll do some division. 18,541 divide by 14,800. That's E to the 4R. Now, here's the thing. We're solving for R. And where is R? It's upstairs. So, how do you get it downstairs? We need to use log. So if what we're solving for is upstairs, log is going to come into our answer. So we're going to take the natural log of both sides. So the natural log of 18,541 divided by 14,800 is 4R, right? Because what am I using here? The natural log of e to the 4R is 4R, right? The exponent comes down. Or that says that the R that we're after is 1/4 the natural log of 18,541 divided by 14,800. Okay. So that's definitely something we don't want to do by hand. That's okay. That's why we have a calculator. All right, so we'll take 1/4, and so I like to use lots of parentheses when I type things into a calculator. So parenthesis 1 divided by 4, times that by the natural log, and we'll take 18541 and divide that by 14800, and we get, coming out, 0.056339329. Okay. Now, notice this is asking it as a percent. So be careful. Check what it's asking for. Since it's asking it as a percent, we say, okay, we need to move our decimal place over 2 spots. So we're going to start with 5. And then we're going to round to 3 decimal points. So we're going to have 5.63. And notice the next thing after, we'd stop here, but we then just sort of check, should we round up or down in the last one? Well, 39 should say round up. So we would have 5.63 and then 4, right? This is from the rounding up. And so that's our answer, 5.634. Ah, that's not so bad. Yeah, these are reasonable numbers. And that's good. By the way, pro check, ask yourself the question, is my answer reasonable? A lot of us have had to deal with money in the past, or we're learning about it right now while we're in college. And so if we had like our R was like 800%, we're like, whoa, hold on. That's not a reasonable number. For R was like 0.00005%, like, okay, something's wrong there. Well, the question is, does it sound like a ballpark of something that could actually happen? And this sounds in the ballpark of something that could actually happen. And so that's a good way to at least check, do I need to go through and maybe see if I had a calculator problem or something? Because it's really easy to mistype things in. And so, all right, but it looks good. So let's keep going. 17. If $21,500 is invested at 5.75% compounded monthly, what is the amount after 8 years? All right. Now notice, we're only doing a one-time investment. So this is not an annuity. So we're investing, and we have a couple of clues here. It's something that's being compounded monthly. Okay. So this is our discrete interest formula. So what does that one look like? Well, that says we have that the amount that we're going to get is what we started with, our principal, then times 1 plus r over m to the mt. This is the same as the formula p, 1 plus I to the power n, where the pieces are, p is the initial amount, r is your interest rate, but as a decimal, m is how frequently per year that you compound, and then t is the number of years. I, well, that's your interest rate per period. So that's your interest rate every month. So I is r over m. N is how frequently you compound, and so it's the number of compounding periods. So that's mt. All right, so we say, well, what do we want? Well, we can see that we're trying to find the amount after 8 years. So we're trying to solve for A. So that's cool. That must mean we know all the other pieces, and we just have to figure it out. So we're looking for words and numbers, really. We see 21,500. We say, okay, that should be our initial amount. So 21,500 is P. R is going to come from the percent, but remember, R is 0.0575, right? You've got to move the decimal over because you need to work with a decimal. M is 12, because it's monthly. So 12. And now T is 8. All right. And so if we put this all together, we're going to get that our amount is 21,500 times 1 plus 0.0575 over 12 to the power 12 times 8. And 12 times 8 is 96, or you could just put 12 times 8. All right. Well, okay. Calculator time. So we're going to take 21,500 times, parenthesis, 1 plus 0.0575, divide by 12, parenthesis, okay, that I need to caret, that means raise it to the 96. And that gives us a grand total of $34,020. And now remember, how are we rounding? Round to the nearest cent. So we have to go 2 digits past 0.196. So if you round up, because 6 is bigger than the halfway point, that'll say round up to the next penny, which would take us to 20 cents. And now we say, okay, does that sound like a reasonable amount? Well, 5.75%. We should be gaining at least somewhere in the neighborhood of a little over $1,000, almost maybe $1,100, $1,200. So after 8 years, we should be at somewhere north of $10,000, but not like ridiculously north. And so it should be somewhere in the 30,000s, probably in the lower end of the 30,000s. So yeah, that just sort of ballpark makes sense. If we had been told, hey, you have millions of dollars in your account, wow, that was too good. Too good. I mean, I wish my investments were that good, but no, it has to be reasonable, and that fits the bill. So $34,020.20. And there you go. All right, great, good. So, a lot of this is going to be making sure you know your formulas and you're using the right formula in the right place. Because you don't want to use the wrong formula in the wrong place. You're very unlikely to succeed. All right. Number 18. In order to accumulate enough money for a down payment on a house, a couple deposits $825 per month into an account paying 3.625% compounded monthly. Very low interest rate. But, all right, if payments are made at the end of each period, how much money will be in the account in 5 years? Now, what do we see? They're putting in $825 per month, right? Payments are made at the end of each month. So it's not one payment, it's many payments. So where are we? We're in the annuities. So the annuities is multiple payments over time. All right, now we have to start asking the question, are we talking future value or present value? So that tells us which formula we need. So let's look at this. How much money will be in the account in 5 years? So that says, hey, down the road, in 5 years from now, how much money is there? That's the future. So we're after a future value. Okay, good. That's good. Now that we know which setting we're in, we say, all right, well, there's a formula for a future value. So future value, and by the way, this is what we're trying to solve for. So this is what we want. What is it? Well, it's our payment times, then there's this fraction, 1 plus I to the power n minus 1 over I. Okay. Now, we should remind ourselves, what do these things represent? So this payment, PMT. This is payment per period. Now, for us, what does that turn out to be? $825 per month. So this is $825. And this is the number of periods. Now, we're doing things in terms of months. So it's not 5, because 5 years, that's not 5 months, right? So 5 years, 12 months per year. So for us, it's 5 times 12, which is 60. What's I? Well, that's interest per period, right? So we have to adjust. So this is a 3.625%. That's the yearly interest, but it's yearly interest compounded monthly. So for us, we first convert this. That's 0.03625, right? Because we move the decimal over, divide by 12. So now we have all the numbers, we have the formula. The rest of it is plugging in. And notice it says round to the nearest dollar. So we're going to follow instructions, right? So we're going to make sure if it says round to the nearest cent, we round to the nearest cent. If it says round to the nearest dollar, we round to the nearest dollar. So our future value, we're going to write this all down and then we'll put it into our calculator, is 825 times 1 plus 0.0365 over 12 to the 60 minus 1 over 0.0365 over 12. All right. There we go. Okay. So, calculator time. Calculator time. All right. That's why, you got to be good at using your calculator, because there's no way you're going to get a number out of that if you don't have a calculator. So 825 times, and make sure, I like to use lots of parentheses here. So parenthesis, 1 plus 0.0365 divide by 12, okay, to the power 60 minus 1, parenthesis. All right, that's the top, divide by, and I'll put parentheses again, 0.0365, 0.0365, divide by 12. And that gives us a number. Okay. Oh, woo, this is interesting. Look at this number, 54,214.50179. Now remember, we have to round to the nearest dollar. So it's 50 cents plus a small sliver more. So we're going to be rounding up. And so we say, this is 54,214.50179. And so like we said, we round up, because it says round to the nearest dollar, $54,215. All right. And there we go. Now, I probably would not put a comma in, but I think you can just put 54,215. I don't know how the system deals with commas for these kinds of numbers. Hopefully it's smart enough. Now, is this reasonable? Now, one way you can ask is it's reasonable is just think, what if there was no interest at all? All right, let's just look at the money they put in. How many times did they put money in? Well, 60 times, because they're monthly for 5 years. So if there was no interest at all, so you take 60 times 825, and you get 49,500. You say, okay, now throw in a little bit of interest, should be, it definitely should be above 49,500, but 3%, that's not a huge number, so it's not going to be ridiculously above that. So a few thousand, that sounds ballpark. That's in the right range. All right, nice. Nice. So there we go. There we go. All right, good. Well, almost there. A few more problems. Number 19. Find I, the rate per period, and N, the number of periods, for the following loan at the given annual rate. Quarterly payments of $2,750 are made for 16 years to repay a loan at 6.4% compounded quarterly. Now, we are not solving this problem. This is about setting the problem up. All right, so we see N is the number of periods. So what are we looking for? Well, you look for two things: how many years, and then how often per year. So you're looking for words like annual, semi-annual, quarterly, monthly. Those are your key words. Well, it says quarterly. You say, okay, so we make 4 payments per year. That's where quarter comes from. And so we say, if you take N is 16 times 4, that gives us 64. So that's our N. Now, we have to do I. Okay, so how do you find I? Well, you look at the 6.4%, and then you say, okay, but wait, you have to, again, you go back to quarterly. It's compounded quarterly. Okay, so what does that mean? Well, I like to say this is R over M, but first thing is you have to convert. It's not 6.4%, it's 0.064, right? Move the decimal over. And then divide by M, well, that's 4 times per year. You can pull your calculator out if you want to, and you may or may not need it, but 0.064 divided by 4, that's 0.016. All right, 0.016. And now, well, what do we put in here? That's the number. Notice this is not a percentage, so don't put a percentage. So it should be a smaller number. And we have to round to 4 decimal places as needed. In this case, we don't need a 4th decimal place or need to do any rounding. But on some problems, you might. And there you go. That's the process. So this one is actually not carrying out a problem. It's just making sure, hey, can you grab the pieces that you need? And so, look for how many years, how often per year, and then convert your interest rate into a decimal, divide by how often per year. And that's the problem. I hope that's not a letdown. Hope you're like, yes, I can do that. All right. Number 20. Solve the following problem. Okay, so we're told N is 60, I is 0.015, payment is 205, and PV is something. All right, now, what is this? Well, there's some clues here. They're essentially asking for a formula. So you start thinking about, hey, is there a formula that we know that uses these symbols? PV, PMT, I, and N. That PMT shows up in annuities. So this is an annuity question. PV is the present value. So this is the present value of an annuity. All right. So that says, hey, we need to know the formula. All right, well, we happen to know the formula. So the formula is that the present value is the payment that you make in each period times 1 minus 1 plus I to the minus N divided by I. Right? Be careful. The present value and the future value are very different formulas. Well, they're not very different. They basically, the difference is Is it 1 plus I to the n minus 1 or 1 minus 1 plus I to the minus n? But, pay attention. Pay attention. All right. Well, we know the numbers, and we're asked to solve for the PV, so that's good. And so we say, okay, fill in what you know. We say, all right, well, we have 205 times 1 minus 1 plus 0.015 to the minus 60 divide by 0.015. Okay. So, here we go. Our last computation. How exciting. How exciting. It will help if I do the right buttons. I accidentally pushed the divide instead of times. Pay attention. So 205 times, parenthesis, 1 minus, and 1 plus 0.015. We can do that in our heads. That's 1.015. And we take that to the power, and I'm going to put parenthesis, minus 60. Yes, know how to put a minus in. Okay, so that's the numerator. And then we're going to divide that by 0.015, and out comes a number. 8072.955121. And all right, now, what do we need to do? We need to round to 2 decimal places. So we're supposed to look here, and we come here and say, since the rest of it's a little bit bigger than a half, we're going to be rounding up. So that would be 8072.96. So that's the present value. 8072.96. And okay, so this is not so crazy, right? We're making 60 payments, and each payment is $200. And so 60 times 200 is 12,000. On the other hand, we have the interest rate is growing over time. There's a lot of periods. So the money way down the line is not worth as much in the present value. And so it should definitely be less than 12,000. But it shouldn't be worth like $100, or it should be worth at least something. And so, yeah, so this is good. If we'd gotten a number bigger than 12,000, we'd be highly suspicious. If we got a number very small and a couple $100, we'd be highly suspicious. And even the first payment, we'd be willing to accept, $200 for just that one payment. But that means a reasonable answer. And a good place for us to stop. All right, well, there we go. 20 problems. And if you're ready, you'll do great. And I hope you do great. You deserve great things to happen. Put in the time, invest. There's a lot of formulas, particularly at the end, so be comfortable with them. But you can do this. You can do this. All right, good luck. I hope to see you again. Bye.